So hi everyone, welcome back to this second video. Now let's understand the process of credit risk modeling. Okay, in this video, let's understand the process of credit risk modeling. Specifically, let's talk about the probability of default model. Okay. So let me first write the steps and then let me make you all understand each and everything. So let me write the steps in at a surface level. So the first step is data cleaning. Okay, so when I say the process, what are the process of credit risk modeling? It means that let's say if you have given a data set. Okay, let me first give you certain background. Let's say if you are given a data set, right? Which I just showed you in the last video. Let's say this is what your data set looks like. Now this data set will be given to you. Now what you have to do as a credit risk modeler or as a quant or as a risk modeler, what do you have to do? So now the first thing is to clean the data. Okay. The first step is to clean the data. Second step is to perform feature engineering. Second step is to perform feature engineering. Third step is to perform, okay. So the third step is to perform data analysis. Okay. It is also called exploratory data analysis, or you can say data analysis. Then feature selection. Then training and testing your model. So once you train and test your model, the next thing is to evaluate the model performance. And the last step is ongoing monitoring. Okay. So this is on a surface level, what are the steps for building a PD model? Okay. So this is what are the steps for building PD model. Okay, let me write this. So these are the steps for building the probability of default model, which is the first component of credit risk. All right. And as I said, PD is what? Probability of default. This is nothing but probability of default. All right. Now what we'll do is let's go into each and every step in detail and let's understand each and everything. First step, data cleaning. So what you have to do in data cleaning, let me tell you. So the first thing you need to check is if in case anywhere you find any duplicate data, and if yes, then remove the duplicate data. See, there are several steps in data cleaning. Okay. And I'm just writing the steps so that you know what all steps have been undertaken in data cleaning. The first step is, of course, to remove the duplicate data. Now, this can be both your row wise data or column wise data. Example of this is, let's say you have a borrower ID. Let's say this is your data set. Let's say borrower ID, let's say loan amount, FICO score, let's say FICO score low, FICO score high, and then default, whether the borrower has default or not. So you'll have 0000101, blah blah blah, like this. If in case you find that you have this borrower ID too is being repeated twice. It's been repeated twice. Does it make sense to have both of them? The answer is no. So this is row wise removal of duplicate data set. Okay. Now, what does column wise removal of duplicate data means? So a lot of times what will happen is, even though, let's say if you see this column name FICO score low, this is FICO score high. A lot of times what you will see is two variables with different names will have the same data. Two variables for different name will have the same data. So let's say if the data is exactly the same, does it make sense to keep both of them? The answer is no. So you will remove either one of them. So let's say let's remove this FICO score high. So this is what we say as column wise removal of data. Okay, is this clear? The first step, is this clear? So remove the duplicate data. This is the first point. Now, second, handle, you need to make sure you handle the missing values. And this is one of the most important steps. Lot of times what will happen is, this data set that is given to you, let's say, you will find that for each variable you have some values missing. Let's say for these variables you have some values missing. What will you do? One easy step is to drop all the missing values. One easiest step is to drop all the missing values. But the question is it done? The answer is no. No, you should not drop the values. Okay, you should not drop all the missing values. Why? What will happen is, because a lot of times when you drop all the missing values, you will lose important informations. So please make sure to not drop all the missing values. Okay. Then the question is, how will you fill those missing values? So there are a lot of techniques to fill those values. So ways to fill the values are mean, median, mode. Then we have forward fill. Okay, forward fill and backward fill are most used in time series data. But let's say then you have mean, mode, median. You have expert judgment. You can use your judgment, or what you can do is you can reach out to business team from where you collected the data. Okay, you can reach out to business team from where to you have collected the data. So a lot of times what will happen is, okay, okay, let me give you an example. Or one more thing you can do is bucket wise filling. Use bucket wise filling the data set. Okay, let me explain you. Let's say you have this variable called FICO score, and you see that for this specific variable, you know there are values, but in some places the values are missing. So what you can do is you can either use mean. Let's say take the mean of this complete data and give it to these. Or, so do you know how to compute mean? Let's say we have three different borrowers, 100, the FICO score is 500, 600, 700. How, how would you calculate mean is? It's nothing but the average. 500 plus 600 plus 700 by 3. The answer would be 600, right? This is what it means by average, right? So what you will fill here? 600. But the question is this the best way to fill in the data? The question is it the best way to fill in the data? The answer is it is not. It is not, because let's say if wherever you find the missing value of FICO, everywhere you are filling 600, but logically that does not make sense. Logically that does not make sense. I'll tell you why. Okay, first let me explain you all these different mean, median, mode, expert judgment, and all these methods. Let's say median. Let's say you have these data 100. Let's say okay, let's say five for FICO you have 400, 450, 550, 500, 650, 600. So can you tell me what will and let's say one more let's say 350. So do you know how do we calculate the median? To calculate the median, what you do is you first arrange in ascending order. First arrange in ascending order. So what will be your case? 350, 400, 450, 500, 550, 600, 650. Now count if it's a even number or a odd number. How many? 1, 2, 3, 4, 5, 6, 7. Is 7 even or odd? It is odd. So when you have a odd number, take the middle value. What will be the middle value? So if you see, divide, this is your middle value. So this will be your median, 500. Okay. And if in case, let's say you have even numbers, let's say your numbers were like this: 350, 400, 450, 550, 600, 650. Now let's count numbers 1, 2, 3, 4, 5, 6. So when you have even numbers, take average of the middle points. Take average of middle. So what is middle? If you see this is your middle, so you'll take average of this. So 450 plus 550 by 2 is how much? 500. So then you will fill what? Median is what? 500. So this you will fill here. You will fill here. Is this clear? Is the concept of, see, mean, everyone know mean is nothing but the average. But is the concept of median clear? How do we compute median? First thing is arrange in ascending order. Second is check if it's even or odd. If it's odd, just take the middle number. If it's even, if the numbers are even, right? Just take the average of the middle 2 points. Just take the average of the middle 2 points. Please tell me, is the concept of median clear? Okay, thank you. So now, so this was the other method, mean, median. Do you all know what is mode? Do you all know what is mode? See, mode is nothing but it is used for categorical based variables. Okay. Let's say something like this. Let's say you have a variable. Let's say you have a variable which is marital status. And in most of the cases, you see single, 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 single. And in some case, and you have this missing data and you have married. So what is mode is it will calculate the frequency of single and married. And whichever has, let's say this is 100 and this is 50. So whichever has higher frequency, which is 100, so 100 times singles are coming, it will fill those. Okay, whichever has higher frequency, it will fill those. That's it. Okay, so to answer Agam's question, this is what we do when we have categorical based imputation, categorical based variable. Okay, this is how you fill for categorical. Again, the question is this the best way? And this is where I'm saying this is not the best way. See, mean, median, board are never the best ways. The best way is to use either expert judgment or do bucket wise filling the data set. I'll tell you how. Let's say, let's say, let's say you have FICO score which is missing. Let's say you have FICO score which is missing. So what I'll do is I'll just, you know, whatever data set I have, whatever data set I have, I'll just let's say I can either, you know, I'll basically bucket all this FICO scores between range 350 to 400, 400 to 450, and let's say 800 to 850. Okay. I'll either bucket this and check what is the interest rate, average of interest rate in all these categories. I will find average of interest rates, average of interest rates. So something like, let's say the lower FICO score means higher credit risk. So these are charged higher percentage, right? Let's say 11%, 10%, 9%, and here it is, let's say 7%. Okay. And now let's say we have this FICO score which is missing. We have a FICO score which is missing. So what I can do is I can check what is the interest rate here. He was charged, let's say he was charged 7%. Let's say he was charged 7%. So I know that, most likely, because the interest rates is charged on a lower side, he must have, the borrower must have a higher FICO score. And that's why, what we'll do is we'll put 800, or let's say we'll put average 825, average of 800 and 850. So either you can do this. Do you think this is a better way of doing it? Instead of just putting mean median mode you cannot put, but instead of just putting mean median, what do you think? Is this a better way? The answer is yes. This is a much better way of filling in the data. Okay. And see, whenever we fill in the data, it is called imputation. It is called imputation. Imputation means to fill in the data. And these are the imputation techniques. Okay. These are the imputation techniques. But to fill in the data, the technical term we use is imputation. Imputation means to fill in the data. Okay. Okay. So we saw, up till now what we saw. First is definitely, okay. First was to remove the duplicate data set. Second was to make sure we handle the missing values. Okay. Agam, I see your doubt. Can you ask by unmuting yourself?
Yeah. Can you explain the second option that you, yeah, this one.
This
That,
one?
yeah. So
Okay.
how can you explain again?
Okay, yeah, no problem. So let's say you have this variable called FICO score. Okay. And you see that, okay, this point is missing. Okay, let's say you saw that, okay, few of your data is missing in this FICO score variable. Okay. Now what will happen is, what you do is you thought, okay, because you have different FICO score, I'll bucket all the FICO score into a 50-50 bin. So you made a bucket of from 350 to 400, 400 to 450, 450 to 500, up till 800 to 850, because I guess the maximum FICO score you can have is 850. Okay. So let's say you bucketed all this FICO score. Now what you're doing is, for all the FICO score, you are checking what was the average of interest rate being charged to the borrowers. What is the average of interest rate? Let's say in the first, this FICO, in the FICO bucket of 350 to 400, let's say you found four borrowers, and the interest rate that was charged was 11%, 11.25, 11.75, 11 point, let's say 12%. So what is the average of this? Average is 11.5. So what you'll do is you'll just allocate to this bucket 11.5%. Okay. So basically what I'm doing is, I'm first bucketing my FICO score into different buckets, and then I'm checking for each bucket what is the average of interest rate. So let's say in this bucket, let's say there are four people. In this bucket, let's say there are 20 people. So what I'm doing is, I'm just calculating the interest rates, average of interest rate for all these 20 people, for all these four people, and so on. Now what I will do is, let's say I need to find this specific, what should be the FICO score here. So what I'll do is, I'll check what was the interest rate charged, what was the interest rate charge. And let's say the interest rate charge was 11.5%. So we know that if the interest rate charge is within is it's somewhere here, we know that this falls into this bucket, right? So we are basically going backwards. So what we are doing is we are going backwards. We know what is the interest rate. So with this we are going backwards. So we know, okay, somewhere between 350 to 400 will be charged. So what I'm doing is, let's take 375 and I'll be allocating 375 here. Now does this make sense?
Yes. What this method called? This one?
Yeah, this see, this one is, you can say this as either bucket wise filling the data, or you can
Okay.
say expert judgment, anything.
Perfect. Yeah. Thank you.
Yeah, basically what you have to do is you need to define the relationship between different variables. That's what you will have to do. Okay. So just for example, I'll give you one more example. Okay. You see this DTI, which we saw, which is nothing but debt to income. Okay. And let's say, in some of the places, income is missing. In some of the places, income is missing. So what I can do is, to find the income, I can do debt by DTI, right? So if I have these two values, I can find these, right? I can find these, right? So I need to make sure, I need to what I have to do is, I need to find relationship between different variables, and that is the best way to fill in the data set. See, mean and median you can always use. Okay, that is the most easiest method, but no one does that. That's what I'm telling you. No one does that because these are the ways you fill in the data set. All right. So this was the second way. The third thing to look into the data cleaning is to correct the data types. To correct the data types. Okay, what does this mean? To correct the data type, what does this mean? This basically means that a lot of times what will happen is, let's say, some of the dates will be like this. Let's say, of course, because we are working with the credit risk data set, we will have origination date, we will have loan maturity date, right? We will have multiple dates like this. Let's say if someone has defaulted, so defaulted date, when the person defaulted, something like this will have multiple dates. And a lot of times when you work with all this data set is, what will happen is, you'll find something like this. Now this is year, month, day. So in this, it was using year, month, and day. In this, the format is different. In this, the format is different. So when I say correct the data type, I basically mean that everything should be in one data type. Either you use this as the standard, and basically correct everything as per this. Okay. So a lot of times all this, and I have seen this also, that a lot of times the data types are incorrect, and you need to make sure that you correct all the data types. Another example of this is, a lot of times numeric variables, by mistake, some if let's say someone writes this FICO score is, let's say the FICO score is 750.51. Now what will you do? See, a lot of times, this should be only in integer format. This should be only in integer format. So what will you do? You will make sure that, okay, if it's in a float type, which is a decimal type, it should be in integer format. So that is what I mean by correcting the data type, making sure that, okay, whatever is in dates, it's in the right date format. If something should be in integer, it should be in integer. If something should be in float, it should be in floating numbers. Floating numbers basically means decimals. Okay. So this is the third thing, which is to correct the data types. Now the fourth thing that you will do in data cleaning is to fix the invalid values. To fix the invalid values. Lot of times, logically something does not make sense. Please tell me, is it possible? Is it possible to have negative interest? Is it possible to have negative loan balance? Is it possible to have negative loan balance, or let's say negative? interest rate. Is it possible? Please tell. The answer is no, it is not possible. Is it possible to have FICO score? Let's say, is it possible to have FICO score of, let's say, 1000? It is not possible. Is it possible to have the default variable as, let's say, 3? No, it is not possible, because we know that default can either be 0 or it can either be 1, wherein 0 means no default and 1 means default, right? So lot of times what you will see is you have to fix invalid values, which means there will be some values which logically won't make sense. Okay, there will be some values which logically won't make sense. So you need to fix those. Okay, you need to fix those. All right, so how can you fix these values? Either, so let's say if you see any negative let's say negative loan balance, you know that loan balance cannot be negative. So what you do is you just take the absolute value of the loan balance. So you take absolute value, which will make this loan balance as positive. Same for interest rate. You can take absolute value of the interest rates. Let's say if in case this, if in case let's say you found something as, okay, the loan default is 3. What you can do is either you can use your expert judgment, look at the FICO score, look at the interest rate being charged, look at the loan amount balance, you know how much balance is paid, was there any default in the past. All this you know all this will help you understand whether to put 0 or 1 for this specific case. Am I making sense? Please tell. Are you all able to understand how to see? One is to identify. Okay, one is to identify, and the other step is to fix all these invalid values. Okay, this was the fourth step. What else? Okay, one important thing is to remove leaky features. What do I mean by this? What do I mean by this? To remove leaky features. A leaky feature is a variable that contains information from the future. Okay, what is leaky feature? A leaky feature or leaky variable is a variable that contains information about the future. Okay, it contains information about the future. And when you are trying to find whether the person will default, whether, and when you are, let's say, when you are trying to find whether the borrower will default or not in the future, you should not have this information. Okay, you should not have this information. Okay, you should not have this information. Just for example, I'll give you a few examples. Let's say, see when you are building the model, it's fine. When you are building the model, let's say you are building the model, then it's fine. Okay, then it's fine. But when you are using the model for prediction, then you need to remove all these variables. Okay, then you need to remove the variables. Example for leaky features are, uh, we cannot have recovery amount. Example for this is, we cannot have recovery amount when we are doing the prediction piece. Do you know why? Can anyone tell me why can we not have recovery amount? If let's say we are building a PD model for prediction, or let's say if we are doing the prediction using this PD model, why cannot we have this? Any guesses? The main reason of why we cannot have recovery amount is because the recovery amount is known only when the default happens. Okay, this variable you know only when the default happens. Recovery amount is what? How much did you recover after the borrower has defaulted? So you are basically telling the model already that okay, this has already happened. So these is what I mean by leaky features, which contains information about the future. Similarly, one more example is one more example is to like final loan balance. One more example is final loan balance. You cannot have this because you don't know the ending balance at the start of the loan, right? You don't know. You don't know the ending balance at the start of the loan. Because see, since you cannot use all these features in prediction. That's why it's very important to make sure all these features are also removed in from here. Okay, that's why it's very important to remove all this from here. So, did you all understand what do I mean by recovery? What do I mean by leaky features? Please tell me. Did you all understand what do I mean by leaky features? Okay, thank you. So this is what I mean by removing leaky features. Okay, which contains information about the future. All right. The next is see we have covered 5 data cleaning steps. The next is there are 2 more. Okay, you need to make sure. Okay, you basically it's debatable which if this specific thing comes into data cleaning or feature engineering. But I would put this in data cleaning only. So, which is encoding categorical variable. Encoding categorical variable. Let's say, let's say you have a categorical variable, let's say marital status, or let's say gender, or whatsoever. Let's say you have single or married. Tell me one thing. If let's say we are building a machine learning model, if you are building a machine learning model, can machine learning model understand the text? The answer is no. Machine learning model only understand numbers. So let's say if it's male, female, the machine learning model only understand numbers, okay? It only understands number. So that's why it's important to convert all the categorical variable into what? Into numbers. How can we convert categorical variables into numbers? There are 2 ways. Okay, there are 2 ways. One is called one hot encoding. Okay, so one is called label encoding and the other is called one hot encoding. Are you all aware about these 2 techniques? Please write yes or no. Do you all know what is label encoding and what is one hot encoding? Okay, let's understand this. What is label encoding? Let's understand this. It's a very simple technique. As I said, both of them are used to convert categories, categories like single, married, male, female, all these different categorical variable into numbers. Okay, all these different categorical variables into numbers. So I'll give you a classic example of label encoding. So if let's say you have let's say something like this, male, female, others, let's say. So how would label encode? Let's say this is your gender column. Okay, so how how will how will one what will label encoding does is it will give, let's say it gives male 0, female 1, and others 2. So what it will do is wherever you have male, it will assign 0 there. Let's say you have something like this, male male. So it will say male is what? So male is 0, then female is 1, others is 2, again male is 0, male is 0. So what it will, so instead of this, it will have this in the data set. This will be your gender column. Okay, this will be, and lot of times you have lot of categorical variables, something like, oh, do you let's say apartment, do you have your own apartment or is it rented? In such cases, what will happen, let's say if I give own as 0, rented as 1, then it will basically assign 0 and 1 here. Okay, this is the first technique of filling in the categorical data with numbers. Okay, so wherever you had text, wherever you have text, it will convert all those to numbers. Why do we do this? Because because eventually we'll be building a logistic regression model or any machine learning model. They do not understand text, they'll not understand this, they only understand numbers. Okay, so this is the first way, which is label encoding. Second is one hot encoding. So what is one hot encoding is, let's say you have um let's say you have a variable. Let me take a perfect example. Okay, let's say education level. So instead of having educate, let's say we have a variable called education level, and this is undergraduate, graduate. This basically tells what is the highest education level you have achieved. Okay, instead of undergraduate, let me write bachelor's, master's. That would be easier to understand. Bachelor's, then we have master's, we have PhD, and lastly postdoc. So what it will do is, so if it was label encoding, it would have done 0, 1, 2, 3, right? If it was label encoding, it would have done 0, 1, 2, 3. But this is not label encoding. This is what? This is one hot encoding. So what one hot encoding does is, it will basically create columns, individual columns. It will basically create individual columns. Bachelor's, master's, PhD, postdoc. So now what will happen, for first it will write 1 because we know it is bachelor's, and for all other it will put 0. For masters it will put 1 here, and for all others it will put 0. PhD it will be here 1, and all others it will be 0. For postdoc it will be this. Did you all understand one hot encoding? And eventually what you do in the end, you drop any one of this. You drop any one of the variable. So let's say, if I drop this, what will be left is masters, PhD, postdoc. And let's take this example. So for masters, PhD, and postdoc, I have 0, 0, 0. So when everything is 0, it basically means it is referring to bachelor's. Okay, and the model will understand it. Okay, do not worry, the model will understand it. So did you all understand this data cleaning? Did you all understand, sorry, the one hot encoding? So what you have to do in one hot encoding is, for each different categories, you'll have different columns, and then in the end you just drop one column. Okay, is this clear? Please tell, is this clear? Okay. Now the last part of data cleaning. I guess it is seventh. And then I'll summarize it. So the last part of data cleaning is what? Outlier detection. What is outlier detection? It is basically nothing but, see, a lot of times you will have outliers in your data set, right? Let's say income. You have income as a variable. Let's say borrower ID 1000. And the income is here is, let's say, $2 million. $2 million is the income. And for all the others, you see income as, let's say, $100,000, $75,000, $50,000, $120,000. So you would see, oh, this is an outlier in my data. Okay, this is what? This is nothing but this will be an outlier in my data, right? If you see what is this part, this is an outlier. This is an outlier in the data, because how will you identify this outlier? See, if you do a box plot, which will look something like this. So you will find this data to be here. Okay, so you will find this data which is $2 million. And whenever you draw a box plot and you see some particle or some observation above or beyond, above or beyond the box plot, then you know that you do have outliers in your variable. Okay, so when you see observations above above or beyond the, the box plot, then you will see, yes, the variable has outliers. The variable has outliers. Okay, so this is one of the way, to understand if if uh, this is one of the way to understand if the variable has outlier or not. But the question is, okay, visually we can see there is an outlier, but but we cannot just filter the data visually, right? I mean, we cannot just filter our very, because see, all this data set these are pretty big. You'll have somewhere close to 50,000 borrowers, or even 100,000 borrowers too. So you'll have a lot of points here. Now, how to identify which are these points? So that's why you use some certain statistical techniques. uh, I can tell you two statistical techniques, which are, first is interquartile range. This is called IQR method, which is interquartile range. And the second method is Z-score method. Okay, let me tell you each of this. Okay, let me tell you each of this. So what is interquartile method? Interquartile method, what is this method? So what this method says is, you calculate the interquartile. See, this is more like a statistics thing we are studying. Okay, you calculate the interquartile. What is interquartile range? So you calculate the interquartile range. What is the interquartile range? It is the difference between quantile 3 and quantile 1. So what is Q3 and what is Q1? So Q3 is nothing but 75 percentile, 75th percentile, and this is 25th percentile of the data. So you basically take the difference between the 75th percentile of the data and 25th percentile of the data. Now tell me one thing, if you have given any examination, be it, let's say, if you are in India, you would have given CAT for your MBA, or let's say GRE if you are preparing for your masters, or GMAT, right? And in the, whenever you receive the scorecard, it is written, oh, you have got 99 percentile, right? You have got 99 percentile. So this is the same thing. This is the same thing. So what is quartile 3 and quartile 1? It is nothing but the 75th and the 25th percentile. So what I'll do is I'll find the lower bound and my upper bound using this quartile. So what is my lower bound? It is nothing but quartile 1 minus 1.5 times IQR. Okay. And what is my upper bound? My upper bound is nothing but quartile 3 plus 1.5 times my IQR. So any observation which is so see, the first step is, see, it's simple, okay? It's not that hard, okay? First step is to calculate the interquartile range, and then what you do is to get the lower bound of the data, you just you use quantile 1 and subtract this range 1.5 times of this range, and you use quantile 3 and you add 1.5 times this range, interquartile range, and then this gives you what, your lower bound and upper bound. So any observation below lower bound, or you can say any observation above the upper bound, is considered to be an outlier. So you can filter all those variable data basically, or filter all those observation. This is the first step, or this is one of the ways of how this is. See, this is one of the ways, and this is the most used. Okay. If you ask me which one is most used between the interquartile and z score, I will say the interquartile range is mostly used. Okay, I'll also explain z score. What is z score? See, in z score, what you do is you measure how many standard deviation of value is from the mean. Okay, so you measure how many standard deviation a value is from the mean. What do I mean by that? So if you see, okay, so I see one question. If we have 100,000 features in the data set, we have to use interconda individual features. Yes. So okay, so that's a very good question. If you have 100, okay, so 100,000 features won't be there. When you say features, that means you means all these variables. Okay. So let's say if you have observation, let's say if you have 100,000 observation, and let's say if you have 100 different column, 100 different variables in your data, right? These are column variables. So for each variable, you'll have to use interquartile range, interquartile method. For each variable, you'll have to use this method. And this range, how will you get? Using this observation. Okay, is this clear? So you'll use this data point. First, you will find the IQR, which is Q3 minus Q1. Then what you'll to find lower bound, Q1 minus 1.5 times IQR. Upper bound is nothing but Q3 plus 1.5 times IQR, and any observation below lower bound or any observation above the upper bound is called an outlier. That's it. Is this clear, Agam? Okay.
Yes.
Okay, thank you. So what is Z score? So you basically measure how many standard deviation a value is from the mean. Okay, let's say you are given income. Okay, so what you'll do is you'll find for each observation, you'll find how many standard deviation the income is from the mean. So what you'll do, you calculate the mean, and then second thing is you'll calculate how many standard deviation the value is from the mean. So let's say if the value is, So basically what we consider is if the Z score is greater than 3, which means 3 standard deviation. If you have any observation or any value which is 3 standard deviation away from the mean, then you will say that is an outlier. Okay, let me give you a graphical representation. So let's say you have this, this is your mean. So let's say this is your first standard deviation, this is your second standard deviation, and this is your third standard deviation. So any observation you see here, this is what we say as outlier. This is what we say as outlier. Okay. So again, this is nothing but one standard deviation. This is two standard deviation, and this is three standard deviation. Okay, is this clear? So any observation that you find, and see how have I gotten this? I'm it's just if you arrange your data and this is from a visual representation of how let's say if you organize your data in histogram format, or if you do any distribution on your data, and basically any observation that you see here, which is after your third standard deviation, this is what we say as outlier. This is what we say as outlier. Okay, is this clear? Please tell. So let me summarize the data cleaning. All right, of course. Okay, let me summarize the data cleaning part again. First step is removing duplicates, removing duplicate data. Second step is to handle the missing values. Again, this can be row wise or column wise, right? Row wise or column wise, removing the data. For this, you have mean, median, mode, or you can use bucket wise, or you can use expert judgment. Okay. Okay, let me not write it because again it will become, oh, okay, it's fine. Let me write it. Okay. So the third is to correct the data types, right? A lot of times you have data in different format, dates in different format, right? Year, month, day. Make sure to correct the data types. Then make sure to fix invalid values, right? Let's say if you see negative interest rates or negative balances, you need to fix all those values. Then fifth is remove the leaky features, remove leaky variables. Sixth is encode categorical variable using two ways, one hot encoding, or let's say local encoding, and one hot encoding. And the last step is removing outliers. Okay, is this clear? Please tell. Please tell, is this clear? All right. So that was all for today. In today's video, we saw what is data cleaning. Now, in the coming sessions, in the next video, what you'll see is how to perform feature engineering. Okay, and then we'll see how to perform. So up till now, what we have covered is just the first part. Okay, what we have covered is just the first part, which is feature engineer data cleaning. And this is the most important step, I would say, and this is one of the toughest steps. Okay, so now once we have done the data cleaning, now the we'll see in the next video how to perform feature engineering and the other steps. All right, so let me stop this recording and then start a new recording.